Welcome to today's technical science lesson. My name is ELECTROLYTIC and my study is Chinese. This lesson is brought to you by the Houghton Department of Education in collaboration with Cyber Discovery Center.
Excellence.
Okay.
Excellence is a habit. Excellence is a quality you have, a quality I have. It's a quality we have when we honor what is true to us. Yes, we are gifted differently. uNkulunkulu akasinganga ngokufana. Excellence is striving for your best. Whenever you have a particular project, test, homework, uzibuze, ask yourself, is this my best? Can I put in more effort? Excellence is striving to be in the top 1% of the area in which you are gifted. And so I challenge you, in every single thing that you do, in every single area that you're gifted in, whether it's sports, it's academic, ucula, whatever that gift is, strive for excellence.
Good day, grade 12 learners. Welcome to today's technical science lesson. My name is Lebogang and my surname is Teledi. And this lesson is brought to you by the Houghton Department of Education in collaboration with Cyber Discovery Center. So for today's knowledge area, we will be talking about chemical change, which consists of 28 marks. And for today's topic, we'll be focusing on the electrolytic cell, which is under your electrochemical cells. And now that is going to be your question 7, that is in paper 2, and it consists of plus minus 12 marks there. Now this is the mark allocation that is regarding your paper 2. You have your section A, which consists of 5 multiple choice questions, and that has about 10 marks there. Then you have your section B, which consists of structured or long questions, and it consists of 65 marks. And the total for paper 2 will therefore be 75 marks, and that is with a duration of 1 hour 30 minutes. The topics to be covered in paper 2 will be under the content of matter and materials, which has a total of 47 marks and a percentage weighting of 62. And the one that we'll be discussing, that is your chemical change, which has a total of 28 marks and a percentage weighting there of 38. Okay. Then this is what you need to know, that is regarding the examination guideline. It says that for electrolytic cells and for galvanic cells, this is what you need to know. But remember, the focus for today will mainly be on the electrolytic cells. So it says that you need to know how to define the electrolytic cells. So you also need to be able to define what? To define the galvanic or the voltaic cell. For the definition of electrolytic cell, it says an electrochemical cell that converts electrical energy to chemical energy, and that it is a non-spontaneous cell. Then for galvanic cell, it says an electrochemical cell that converts chemical energy to electrical energy, and that it is what? It is a spontaneous cell. So those are also the difference between the two, the electrolytic and the galvanic cell. The electrolytic cell converts what? Electrical energy to chemical energy, but the galvanic cell then converts chemical energy to electrical energy. And the difference again is that the galvanic cell is spontaneous, while the electrolytic cell is what? Is non-spontaneous. Okay, so again, we need to know how to define what? How to define electrolyte. So it says define electrolyte as a solution or a liquid dissolved or a dissolved substance that conducts electricity, that is through the movement of what? That is through the movement of ions. So you need to keep in mind that we are going to be using an electrolyte that is for both the electrolytic cell as well as the galvanic cell there. Then next, according to the examination guideline, it says understanding the processes and redox reactions that are taking place where? That are taking place in the electrolytic cell. So we need to know how to describe what? How to describe the movement of ions in the solution. And then it says state the direction of the electron flow that is in the external circuit. Then we need to know how to write half reactions that are taking place at the anode as well as at the cathode there. Then it says we need to write down the overall cell reaction, and that is by combining what? That is by combining the two what? The two half reactions. Then it says describe using half reactions and the equation for the overall cell reaction as well as the layout of the particular cell using a schematic diagram. And then it says the following electrolytic processes. So we need to know the decomposition of what? Copper 2 chloride and electroplating a metal. That is by what? That is by another metal there. Okay. So now, just to recap, when it comes to the galvanic cell is composed of what? Is made up of the two half cells there. So those two half cells, they have what we call what? They have what we call electrodes. So on the left hand side here, we have the zinc electrode, and on the right hand side, we have what? We have the copper electrode. So remember, the anode will be what? Will be the electrode where oxidation will take place, and the cathode will be the what? Will be the electrode where reduction will take place. Okay, so we have the two electrodes, and we discussed that in order for us to determine which one is going to undergo oxidation and which one is going to undergo reduction, remember we said that we are going to be using what? We are going to be using table 4b. And we said that if we use table 4b, whatever that will be appearing at the top of the table, that will then represent our anode, and the B will therefore represent the salt bridge. So we are going to use the B whenever we have to write the what? Whenever we have to write the cell notation there. And then we said that whatever that will then appear below the anode will therefore be representing the cathode. So we are therefore saying that A represents the anode, and then B is the salt bridge, and then C will represent the cathode there. But that is using what? That is using table 4b. And then we said that in the two half cells, we are going to have what? We are going to have our electrolytes there. So when it comes to the zinc, we have zinc nitrate as the electrolyte. And then when it comes to the copper, we have our copper nitrate there as our electrolyte. Then we discussed as well the oxidation, the oxidation half reaction. And the oxidation half reaction is going to occur, which side is going to occur by the anode. Okay, because we are saying that the anode is the electrode where what is the electrode where oxidation will take place. And as well as the reduction half reaction, it is going to occur where? It is going to occur by the cathode. And then again, we have what? We have the movement of electrons. And we are therefore saying that when it comes to the movement of electrons, electrons are going to be moving from which side? Electrons are going to be moving from the anode. So electrons are going to be moving from the anode all the way to the cathode. So in this case, our anode is what? Our anode is the zinc and our cathode is the copper. So electrons are going to be moving from the anode, the zinc, to the copper. And then again, we have what we call the polarity. So in terms of polarity, we are saying that the anode will be negative, and we are therefore saying that the cathode will be what? The cathode will be positive. So when it comes to a galvanic cell, we can therefore use what? We can therefore use the word what? Again there. So whereby G will represent what? The galvanic cell. In the galvanic cell, the A will therefore represent the anode is what? The anode is negative. So the G, we are saying the galvanic cell, the A, the anode, and then we are therefore saying the N, the anode is what? The anode is negative. So if the anode is positive, it will therefore mean that the cathode is therefore what? The cathode is therefore positive. Okay. Then we are therefore saying again that as oxidation is taking place, meaning now we have Zn solid. So Zn solid is represented by what? By the electrode. We have Zn solid moving into Zn2 plus what? Zn2 plus aqueous. So as that is happening, we are therefore saying that there will be a movement of what? There will be a movement of electrons. Okay. So as we have the movement of electrons, we are therefore saying that the zinc electrode will therefore do what? It will therefore decrease in what? It will therefore decrease when it comes to the mass. Now on the cathode side, we are saying that Cu2 plus is going to move to Cu solid. So Cu2 plus aqueous, we are moving from the electrolyte aqueous. Cu solid, it means that we are moving to the copper. So hence we have what? We have the solid there. So as that is happening, as we then gain electrons when it comes to the cathode, we are therefore saying that what is going to happen then? The cathode is going to increase in what? The cathode is going to increase when it comes to the size. Then again, we have what we call the salt bridge. So the salt bridge is going to contain a salt which contains what? Which contains cations and what? And anions. So in this case, the sodium, what does it represent? It represents the cation because it has a positive charge. And then the chloride ion, it represents what? It represents an anion because it has a negative charge. So therefore, with those ions, remember for us to neutralize the two electrolytes, what is it that we are going to do? So to maintain electrical neutrality, we are therefore going to be using what? We are therefore going to be using the salt bridge. So remember, we said that when it comes to the anode, Zn solid is moving into what? Into Zn2 plus aqueous. So meaning Zn solid, if it's going into solution, we are therefore saying that when it comes to the zinc, anode, we are therefore going to have a lot of what? A lot of Zn2 plus ions in what? In solution there. So if we end up having a lot of Zn2 plus ions in solution, how are we going to use the cations and the anions in the salt bridge? That is to neutralize the electrolytes. So we are therefore saying that the anions, which are negative, are therefore going to move onto the side of the anode. Why? Because when it comes to the anode, we have a lot of Zn2 plus ions. So we have a lot of positive charges when it comes to the ions, and those positive charges are your what? Are your Zn2 plus ions there. So therefore, we are saying that the N ions are then going to move to the what? To the anode, okay? And then now when it comes to the copper, which is our cathode, what is going to happen? We are saying that the Cu2 plus ions is going to move from the solution to the solid. So meaning that Cu2 plus ions, we are moving from the electrolyte. Where are we moving to? So we are moving from the electrolyte and we are therefore moving to the electrode. So as that is happening, it therefore means that we are going to have a decrease in the number of what? In the number of Cu2 plus ions in solution. So as we have that decrease, it therefore means that when it comes to the copper electrode, we are going to have a lot of nitrate ions in what? In solution. Where are the nitrate ions coming from? They are coming from the electrolyte there. So from the electrolyte, we have Cu2 plus and what? And NO3 minus, okay? So therefore, we are going to have a lot of NO3 minus when it comes to the copper electrode. And when that happens, because we are going to have a build-up of the negative charges there when it comes to the copper electrode, the Sol bridge will then want to neutralize the electrolyte by bringing in the what? By bringing in the sodium ions. So when that happens, then we are therefore saying that the cation ions, so the cation ions are positively charged, they are going to migrate to the copper electrode. Why? Because now we have a buildup of what? We have a buildup of the negative charges when it comes to the electrode. So that is one of the functions now of the Sol bridge. That is to maintain what? To maintain electrical neutrality between the two half cells. And again, the function of the Sol bridge is to what? Is to complete the cell. So we are saying that if we do not have the Sol bridge, then the cell will be what? The cell will be incomplete. So if the cell is incomplete, when it comes to the voltmeter as well, we are saying that it therefore means that we are not going to have a reading when it comes to the voltmeter there. Okay. So now we are going to move on to the electrolytic cell. Now that we have done a recap on the galvanic cell then. So electrolytic cell, it says it is a cell that converts what? That converts electrical energy to chemical energy. Okay, so remember, this is a definition. And when it comes to definition, remember that we are going to define according to the examination guidelines. Now it says electrolytic cells are what? They are non-spontaneous. So if we say that they are non-spontaneous, it therefore means that they need heat, they need electricity, or they need what? Or they will need heat to occur there. Okay. So now on this picture here, we have an example of a what? An example of a electrolytic cell. So now learners, if you have any questions, you can send your questions to the following WhatsApp number, 079-578-2908. If you have any questions, you can send your questions to the following WhatsApp number, 079-578-2908. Then it says the following is an electrolytic cell. So it has a battery, or in this case, we can also call it what? We can also call it a cell. So this battery is then a source of what? Is then a source of electricity. So it says here, a source of electricity is therefore required for what? It is therefore required in terms of the electrolytic cell then. Okay. Then it says an electrolytic cell is a type of cell that uses electricity to drive what? To drive a non-spontaneous reaction. Okay. So remember we said that when it comes to the energy conversion, we are going to use what? We are going to use electrical energy and convert it to what? To chemical energy then. When electricity flows through an electrolyte, a solution containing ions, the ions undergo a chemical reaction. This process is called what? Electrolysis, and it takes place in an electrolytic cell. Okay, then it says electrolysis is the chemical process in which what? In which electrical energy, so we spoke about this, we said when it comes to conversion, we are going to have what? Electrical energy to what? To chemical energy. So remember again, when it comes to the exam, they can ask you the energy conversion when it comes to the electrolytic cell, as well as the energy conversion when it comes to the what? To the galvanic cell then. And then it says, or the use of what? The use of electrical energy, that is to produce what? That is to produce a chemical change. So the same as the definition there, we are using electrical energy to convert to what? To chemical energy then. Then it says an electrolytic cell consists of two electrodes. So again, we have two electrodes that are in contact with what? The two electrodes will be in contact with the electrolyte. So on the electrolytic cell then, this will be our electrolyte, that is our copper 2 chloride. And then it says that then brings about a chemical reaction when connected to an outside source of what? To an outside source of electricity then. And then an electrolyte is the substance of which the aqueous solution contains ions. So that is the very same definition that we used again when it comes to what? When it comes to the galvanic cell there. So the aqueous solution contains ions. So if it's copper 2 chloride, it therefore means that in terms of ions, it's going to be Cu2 plus and what? And Cl minus. Okay, so this solution, the copper 2 chloride, is the same as, if we break it down into ions, it's the same as Cu2 plus and Cl minus ions there. Then it says, or a substance that dissolves in water. So this substance will then dissolve in water, and that is to give us a solution that will be able to do what? That will be able to conduct electricity. And then it says an electrode is an electrical conductor. So again, electrical conductor that is used to make contact with the metallic part of the circuit there. Okay. On the next one, it says the electrolyte solution consists of the metal cations as well as the what? As well as the spectator ions. So for example, when it comes to Cu2 plus and Cl minus, we can therefore say that our Cu2 plus will therefore be our metal what? Our metal cation, and we can therefore say that the Cl minus can therefore be representing our spectator ion. Okay, then it says the electrodes are made of a metal or a carbon. Okay, and the electrodes in the electrolytic cell can be the same metal, or we can have different what? We can have different metals. So again, we are saying that when it comes to what? When it comes to an electrolytic cell, we are therefore saying that when it comes to the two electrodes, they can be made of what? They can be made of different metals. For example, on the one, we can have carbon, and on the other one, we can therefore have what? We can therefore have our copper there. Then it says when connected to direct current, one electrode becomes positively charged and the other electrode becomes what? Becomes negatively charged. So how will you then see which one is positively charged and which one is then negatively charged? So it therefore means that you are going to use your cell or your battery as an indication. And remember, from electricity, we are saying that the longer line will represent the positive terminal and the shorter line will represent the what? The negative terminal. So that knowledge of electricity, we are therefore going to use it when it comes to what? When it comes to the electrolytic cell. Then it says this initiates the movement of ions in the electrolyte towards the electrodes. Positive ions move towards the negative electrodes. So if in solution we have Cu2 plus and Cl minus, we are therefore saying that the positive ions in solution, so the positive ions are going to move towards the what? Towards the negative electrode there. And the chloride ion is negative. So negative ions are therefore going to move towards the positive electrode. And then we have here, it says, in an electrolytic cell, the positive terminal of the battery is called the what? Is called the anode. So again, how will you then see? We are going to use that knowledge when it comes to what? That knowledge of electricity. We are saying that the longer line, it represents what? The positive terminal of the cell or of the battery. And the smaller line or the shorter line represents the negative terminal of the battery. So we are therefore saying that when it comes to the electrolytic cell, the positive terminal of the battery or of the cell, it represents the anode. Then it says, however, the anode should not be defined in terms of an electrode, but it should be described in terms of the reaction that is occurring there. So what is it that we know about the anode? It says, hence, the anode is defined as the what? As the electrode where oxidation will do what? Where oxidation will take place. Then we have the negative electrode. So the negative electrode, we are saying that it is going to be represented by the smaller line there or the shorter line. Then it says, but the correct definition of the cathode is what? We are going to define it as the electrode where what? Where reduction is going to take place there. When it comes to then, we have what we call the electrolysis of copper chloride, okay? So there are 3 stages when it comes to electrolysis. And number 1, what we need to do, even when it comes to the examination, is that we need to break down what? We need to break down the electrolyte. So in this case, what do we have? We have copper 2 chloride. And then we said that copper 2 chloride, it then becomes what? It then becomes Cu2 plus and what? And Cl minus, okay? So we break it down to Cu2 plus and Cl minus. Then, as another example, if we are given a sodium chloride as the electrolyte, you need to know how to break it down. So sodium then is on group number 1 when it comes to the periodic table. So it's going to have a charge of +1, and the chlorine is group number 7 when it comes to the periodic table. So it's going to have a charge of -1 there. And then if you are to break down this electrolyte, silver sulfate, what are you going to have? Silver is a transition metal. So therefore, we are saying that the charge on the silver will be Ag+, and SO4 is a polyatomic ion. So therefore, we know that the charge of the SO4 will therefore be what? Will therefore be 2 minus there. Then if we have a copper sulfate, copper is a transition metal, so therefore the charge that we have for copper is 2 plus, and the charge that we have for the sulfate will be SO4 2 minus. So step number 1, we are saying that we need to break down the electrolyte. So in this case now, on this cell, we are given what? We are given copper 2 nitrate. We said that copper is a transition metal, and then we said that the chlorine is on group number 7, hence that's why we have it as a charge of what? Of -1 there. Number 2, then we can then talk about what? The migration or the movement of ions. So what is going to happen? After you have then broken down the electrolytes, we are therefore saying that the N ions, which ones are the N ions? The N ions are negative. So the N ions are going to migrate to the anode. And the cation ions are going to migrate to the cathode. So let us now have a look. We said, how do we identify? If we are to use our cell or our battery, we said the longer one represents the positive terminal and the shorter one represents the negative terminal. So the N ions are negative. They are going to migrate toward to the anode, which is positive. And the cation ions are what? The cation ions are positive, so they are going to migrate to the cathode, which is what? Which is negative. So from here then we have step number 3. So step number 3 then, that is when we can then apply what? That is when we can apply redox, okay? So when we apply redox, we are therefore going to say that the red is the reduction, a half reaction, and then the ox. Remember, we said that that's the oxidation half reaction. So we'll have a reduction occurring where? At the cathode, and then we'll have what? Oxidation that is occurring at the anode. And then when it comes to the oxidizing agents, we are therefore saying that we are going to have the oxidizing agent when it comes to what? To reduction or the cathode, and then we are going to relate the reducing agent to oxidation or to the anode, okay? So step number 1, we said we are going to break down the electrolyte. And step number 2, we said that we are going to talk about what? The migration of what? The migration of ions. So this one is the positive terminal, this one is the negative terminal. And then we said that the chloride ions, so they are N ions, they are going to migrate to where? They are going to migrate to the anode. And then we said the cation ions, which are positive, are therefore going to migrate to the what? Are therefore going to migrate to the cathode, which is negative. So then if you then want to write the oxidation and the reduction half reaction, let's say, for example, now we are given what? We are given copper as the we are given copper as our what? We are given copper as our electrodes. And they now want you to write there what is occurring at the anode and what is occurring at the cathode. So this is now what we are going to do. We are therefore going to say that because the chloride ion has migrated to the anode, it therefore means that that is where we are going to have the what? The oxidation half reaction. And because the Cu2 plus ion has migrated to the cathode, that is where we are going to have the reduction half reaction, okay? So it therefore means that you are then going to use your table 4b to write the half reaction, that is in terms of what? Cu2 plus, and the half reaction in terms of Cl minus. So on your table, you will see that copper is appearing as what? Cu2 plus by 2 electrons, and that is to give us what? That is to give us Cu there. So it's Cu aqueous to give us Cu at Cu solid. So you are then going to write what? You are then going to write the copper that is in terms of what? the copper in terms of reduction. So this will therefore represent your reduction half reaction. So remember we said that when it comes to reduction, we are going to copy and paste. So you will see that your copper appears as Cu2 plus by 2 electrons, and it has the 2 arrows to give us Cu. But once you have then decided on whether the copper is undergoing oxidation or reduction, remember you are going to use what? You are going to use a single arrow. And this copper, when you write the reduction half reaction, you are going to write it from the left to the right. So if you write it from the left to the right, you will see that you are going to start with what? With Cu2 plus by 2 electrons. And on the right, so you are going to have that single arrow. And then on the right, you are going to have what? You are going to have your Cu there. Then, so this would then represent your reduction half reaction. Then from there, you need to write your what? You need to write your oxidation half reaction. So how will you get your oxidation half reaction? The oxidation half reaction will come from the what? Will come from the chlorine. So because the chlorine has migrated to the what? Has migrated to the anode, it therefore means that the chlorine will undergo what? Oxidation. Then it means that you are then going to go to your table and look at chlorine. So chlorine will then appear as Cl2 gas plus by 2 electrons, and that is to give us 2Cl minus. So remember, if you are to write the oxidation half reaction, what is it that you are going to do? It means that you are going to write it from the right to the what? From the right to the left. So if you do that, then this will be your oxidation half reaction. So you will have 2Cl minus, starting with the chlorine, because we said it's going to be from the right to the left. But remember, your arrow must then face to the right. So we'll have Cl2 gas plus by what? Plus by 2 electrons. So from there, it therefore means that we have now written the oxidation half reaction. So, but this will apply only if you have what? Only if you have carbon being used as your electrode there. Okay, so from there we are able to identify the oxidizing agent. So remember we said that the oxidizing agent, we are going to associate it with what? With reduction. And if you have written the correct half reaction, that is in terms of reduction, therefore your oxidizing agent will be represented by what? Will be represented by the reactant. So this is then your oxidizing agent. And then we can then also identify the what? The strong or the strongest what? Reducing agent from here. So again, for the reducing agent, we are going to associate it with what? With oxidation. So if we have now written the correct half reaction, that is in terms of oxidation, we can therefore say that the reducing agent will be represented by what? The reducing agent will therefore be represented by the reactant there. Then we can then observe what is now going to happen, that is in terms of the anode, and what is going to happen in terms of the what? In terms of the cathode there. So remember, for the anode half reaction, we said that we are therefore going to have what? We are going to have 2Cl minus Cl2 gas plus by what? Plus by 2 electrons. So that is our anode half reaction. And for the cathode half reaction, we said we are going to have Cu2 plus by 2 electrons, and that is to give us Cu. So because we have a charge there, it will be aqueous. And then on this one, we don't have a charge, so therefore it will be a solid. And then this one will be aqueous as well. Okay. So we have the anode, and then we also have the what? We also have the cathode there. So what is now going to happen with regard to the anode? It says here bubbles will be observed at the positive electrode as the cell proceeds. So which one is positive? The longer one is positive and the shorter one is what is negative. So as the cell proceeds, we are saying that bubbles will be observed, and these bubbles will therefore be observed. And where are they coming from? They will be coming from the chlorine. So the Cl2 gas. Then it says chlorine gas is what? Chlorine gas is green in color. And therefore, we are saying that when it comes to the anode, it will not decrease when it comes to the size, okay? The anode will not decrease when it comes to the size, because now, where are we moving from? So we are moving from aqueous, and what is it that we are forming? So when it comes to the anode, we are going to be forming, so these dots here can also be representing what? We are going to be forming bubbles, and those bubbles, we are saying they will be formed from the chlorine. So because of that, therefore, the anode size will not change. The anode size will remain the same. Then we have what? Then we have the cathode. So it says here the cathode is going to increase in mass. Why is the cathode going to increase in mass? So remember, we said that with the first step, we had broken down the what? We had broken down the electrolytes, and then we said that the chloride ion will migrate to the anode, the Cu2 plus ion will migrate to the what? Will migrate to the cathode. So now this is what we are saying. When it comes to the copper, we are moving from Cu2 plus. So meaning we are moving from the electrolyte, there is the Cu2 plus. Where are we moving to? So we are moving from the Cu2 plus to Cu solid. When we are doing that, it therefore means that the cathode, so after some time, the cathode will do what? The cathode will therefore increase in what? The cathode will therefore increase when it comes to the mass, because we are moving from Cu2 plus ions, which is from the electrolyte to Cu solid. Then it says here the concentration of the electrolyte, will therefore do what? The concentration of the electrolyte will therefore decrease, okay? Why will the concentration of the electrolyte decrease? Because the Cu2 plus is reduced and it is not replaced. So we are saying that because this one, Cu2 plus, where is it moving? It's moving from the electrolyte to the what? It's moving from the electrolyte and it's moving to the electrode here, which is the copper. So when that is happening, what do we have when it comes to the anode? When it comes to the anode, we have bubbles or the chlorine gas being produced. So because now the anode is producing the chlorine gas, we are saying that the Cu2 plus is not replaced in solution. So because it is not replaced in solution, we are saying that after some time, this electrolyte here is therefore going to do what? The electrolyte is going to decrease, or the concentration of this electrolyte is therefore going to do what? Is going to decrease there. So again, learners, if you have any questions, you can send your questions to the following WhatsApp number, 079-578-2908. If you have any questions, you can send your questions to the following WhatsApp number, 079-578 and 2908 there. Okay, so next we have electroplating. So it says here, electroplating, it is the covering a metal or a substance with another metal, and that is for protection against the rust. And again, we are covering for economic value. Then it says to cover with silver, we are going to use what? We are going to use a silver salt. So by the word silver salt, what are we referring to? We are referring to the electrolyte there. So if we want to cover another metal with silver, we are saying that we need to use what? A silver salt. So for example, we can use what? A silver sulfate. So this is a silver salt. And when it comes to the anode, we need to use what? We need to use a silver anode as well. So it's three things here: silver anode, silver salt, and that is for us to cover with what? That is for us to cover with silver there. Then it says we need to connect the material to be covered to the what? To the cathode. Okay. And then to electroplate a non-conducting material, first cover the material with carbon, and that is to allow the electricity to do what? To flow through there. So again, we said when it comes to the steps, what are we going to do? We are going to break down the electrolyte. So as an example, now we have what? We have silver nitrate then. And then if we then have the silver nitrate and we break it down, silver is a transition metal. So we are therefore saying that it's going to have a charge of +1. And then the NO3 is a polyatomic ion. So we are therefore saying that it's going to have a charge of what? NO3 minus. So we break down the electrolyte, meaning this is what we are going to have in solution, or when it comes to the electrolyte. So from there, remember we said the positive electrode will represent the what? The positive electrode will represent the anode, and the negative electrode will represent the cathode. Okay, so the negative one, so the negative electrode will represent the cathode, and the positive electrode will represent the what? Will represent the anode. Okay, so from there we are therefore going to now talk about what? The migration or the movement of what? The movement of ions. Okay, so but before we then talk about that, remember we said that if we want to cover with silver, then what are we going to use? We are going to use silver as the anode. And remember we said that the material that we want to cover, where are we going to connect it to? We are going to connect it to the cathode there. So from there, when it comes to the migration or the movement of ions, the N ions, remember we said they are going to migrate to the anode. So the N ions in this case are represented by what? By NO3 minus, and the cations are going to migrate to the what? Are going to migrate to the cathode. Okay, so the N ions, remember we said that the NO3 minus in this case is going to be representing the what? Is going to represent the spectator ion. So if it's a spectator ion, it therefore means that it will not participate in the reaction there. So from there, cations, we are saying they migrate where? They migrate to the cathode. Then number 3, we need to talk about what? Reduction and oxidation. Okay, so if we then talk about reduction and oxidation reaction, it therefore means that you are going to look at your table. And if you look at silver on your table, you will see that the silver is written in this way. So from here, when it comes to electroplating, we are saying that the silver will have to be written in terms of oxidation, and it will also have to be written in terms of what? In terms of reduction. So how will you write the silver in terms of oxidation? You are going to therefore write it from the right to the left. So it will be silver is silver into what? Into Ag plus by 1 electron. So this will then represent your what? This will then represent your oxidation half reaction. So if you would like to write the reduction half reaction, remember we said that you are going to copy and paste. So if you copy and paste, you are going to have Ag plus by 1 electron, and that is to give us what? That is to give us Ag there. So those are your two half reaction in terms of oxidation, and the other reaction is in terms of reduction. And number 3 again, we are going to do what? Identify which one is the oxidizing agent and which one is the reducing agent. So if you already have your reactions to say this is your oxidation half reaction and this is your reduction half reaction, remember we said that we are going to associate what? Strong oxidizing agent with what? With reduction. So which one is the reduction half reaction? We said this will represent the reduction half reaction. So if that's the case, it therefore means the Ag plus, not the Ag, but the Ag plus is the oxidizing agent. And then if we are to talk about the strong reducing agent, we are going to associate it with what? With oxidation. So if that's the case, then we are saying only Ag, not Ag plus, will represent your what? Will represent your reducing agent. Because we said, how do we then write the agents? We said that for you to be able to write the agents, you need to be able to write the correct oxidation half reaction and the correct reduction half reaction. From there, if you have written the correct oxidation half reaction or the correct half reaction, you will then know that your agents will act as your reactants. As your reactants, meaning that they will be on the left side of the what? On the left side of the arrow. Okay. So now, when it comes to the interpretation now, this is what we are saying. So if you have your two reactions, Ag to give us Ag plus by 1 electron and Ag plus by 1 electron to give us Ag. This is now what we are saying. When it comes to the cathode, remember this reaction is the one that represents what? Is the one that represents the cathode. So when it comes to the cathode, we are saying that the cathode is going to do what? The cathode is going to increase in size. So if the cathode increases in size, we are therefore going to write the phases here. So it therefore means that Ag plus is moving from where? Is moving from the solution or from the electrolyte to the what? To the electrode. So if that is happening from this reaction, we are saying Ag plus aqueous. So aqueous meaning we are moving from the electrolyte. Where are we moving to? We are moving to the electrode. So Ag solid, we are moving to the electrode. So therefore, the cathode is going to do what? The cathode is going to increase in size. Then it says the key is then covered with what? The key will therefore be covered with the silver now. And then now when it comes to the anode, so this is your half reaction when it comes to the what? When it comes to the anode. So when it comes to the anode, where are we moving from? We are moving from the solid. So we are moving from the solid, which is the electrode. And where are we moving to? We are moving into the electrolyte, or we are moving into the electrolyte. So if we are moving from the solid, which is the electrode, to the electrolyte, we are therefore going to do what? The anode is going to do what? Is going to decrease in size. So if the anode is decreasing in size and the cathode is increasing in size, what will happen to the concentration of the electrolyte? So the concentration of the electrolyte will do what? It will remain the same. Why will it remain the same? Because when it comes to the anode, what are we doing? We are moving, so we are producing Ag plus as we are moving from Ag, the electrode, to the electrolyte. So we are producing Ag plus in solution. So even though we are producing, when it comes to the cathode, what is happening? We are removing Ag plus. So we are removing Ag plus from the solution to the electrode. So because that is happening, therefore the concentration of the electrolyte will therefore remain the same. So now when it comes to questions, they can then ask you what will happen to what will happen to the size when it comes to the cathode, and what will happen to the size when it comes to the anode, as well as what will happen to the concentration, and as well as for you to be able to write down the half reaction, that is in terms of oxidation, and the half reaction when it comes to a reduction there. Okay. So learners, we are going to take now a 3 minutes break there. Welcome back, learners. So if you have any questions, you can send your questions to the following WhatsApp number, 079-578-2908. So again, if you have any questions, you can send your questions to the following WhatsApp number, 079-578 and 2908 there. Okay, so the question now here says, the diagram below represents what? An electrolytic cell that is used for the decomposition of copper 2 chloride. So that copper 2 chloride, we know that it represents the what? It represents the electrolyte. So your copper 2 chloride is Cu2 plus and what? And Cl minus. And that is what we have in what? In solution. So if you are maybe just to combine it, remember it's going to be what? The 2 will then go there to the chlorine and the 1 will then go to the copper. So you will have Cu Cl2, and that is for your electrolyte. Now it says graphite electrodes are used in the cell, okay? So remember, when we speak of graphite, we are therefore referring to what? We are therefore referring to the carbon. Now it says here, 5.1, for the electrolyte used in the cell above, write down the name of the cation and the name of the what? The name of the anion. So remember we said that the positive charges are going to represent what? The positive charges, they represent the cations, and the negative charges, they represent the anions. So if we are then looking at the electrolyte, we can see that we have Cu2 plus. So Cu2 plus will be the cation, and Cl minus will therefore represent the what? Cl minus will therefore represent the anion. So now the question said that we need to write down the what? We need to write down the name. So that is very important. If they said that you must write down the symbol when it comes to the cation, it therefore means that we were going to write Cu2 plus. But because they said that we must write down the name will therefore be represented by what? By copper 2 ions. And then next we have what? We have the anion. So if they say that we must write the symbol will therefore be represented by what? By Cl minus. That is our anion. But if we are to write the name will therefore not be chlorine. So this is chlorine Cl. But because it has a charge, because it is Cl minus, therefore the name will be what? Will be chloride ion or chloride ions then. And then 5.2 says which electrode represents the what? Represents the anode, and which electrode represents the cathode. So again, remember we said that the longer line represent the positive terminal of the cell or of the battery, and the shorter one represents the negative terminal of the cell or of the battery there. So which one will therefore represent the anode? The anode, remember we said when it comes to an electrolytic cell, the anode will be represented by the positive terminal. So again, maybe just to remember, we can also use this. Remember we said for the galvanic cell, we said GAN, and then for the electrolytic cell, we are going to use APE. So GAN, we said the galvanic cell, it means that the anode is what? Is negative. And then for the electrolytic cell, we are going to use APE or APE, whereby the anode is what? Is positive when it comes to what? When it comes to the electrolytic cell. So if we are going to use this and we are saying that the anode is positive, if the anode is positive, therefore, even if we don't have the cathode, then we will automatically know that the cathode is what? The cathode is negative then. So which electrode then represents the following? Which one will represent the anode? So we are saying if we use the APE, we are saying that the anode is what? The anode is positive where? In an electrolytic cell. So it will therefore be the positive electrode. And which one will represent the cathode? We are saying that if we use this to get the anode, then we will know that the cathode is the what? The cathode is the negative electrode there. Then we have 5.3. It says we need to define what? We need to define the term oxidation. So our definition, remember we said we are going to use what? Oil, whereby oxidation is what? Oxidation is loss, and that is the loss of what? The loss of electrons. Or we said that we are going to define oxidation as what? As an increase when it comes to the oxidation numbers. Now 5.4 now says write down a balanced half reaction that occurs that will occur where? That will occur at the positive electrode. Okay, so for you to be able to then write the balanced half reaction at the positive electrode, you need to know what the positive electrode is. So we said that the positive electrode, we said that the anode is positive where? In the electrolytic cell. So the positive electrode is therefore represented by what? Is therefore represented by the anode. So if we are to use those steps, we said step number 1, we are going to do what? We are going to break down the electrolyte. So remember when it comes to the electrolyte, what is it that we had there? What is it that we had? We had Cu2 plus and what? And Cl minus. Okay. 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 So it says here, write down the balanced half reaction that occurs at the positive electrode. So it therefore means that when it comes to the migration of ions, we said that the N ions will migrate where? The N ions will migrate to the anode. So we had what? We had Cu2 plus and Cl minus. So it therefore means that the Cl minus was our N ions, and it will therefore migrate where? It will therefore migrate to the anode electrode. So if the Cl minus are migrating to the anode electrode, we are therefore then going to use what? We are therefore going to use the chlorine to be able to write the half reaction that is occurring where? That is occurring when it comes to the positive electrode then. So what do we have then? So if you look at your table, then you are then going to look at what? You are then going to look at your chlorine. So your chlorine, you then need to write your half reaction that is in terms of what? That is in terms of oxidation. So when you do that, then you write it from the right to the left. You are going to have what? 2Cl minus aqueous to give us what? Cl2 gas plus by what? Plus by 2 electrons. So this will then be representing what? The half reaction that is occurring where? At the anode, or the half reaction that is in terms of what? Oxidation. Then we have 5.5, which says define the term what? Reducing agent. So it says a reducing agent is a substance that is what? A substance that is oxidized, or a substance that will do what? Or a substance that will lose electrons. So remember we said that what are we going to associate the reducing agent with? We are going to associate the reducing agent with oxidation. So if you are now asked to identify the reducing agent, it therefore means that what will then represent your reducing agent? The Cl minus will therefore represent your reducing agent there. Then it says 5.6, draw a diagram showing a cell that is used to electroplate what? A spoon with silver, and that is using what? A battery, and then you need to indicate the following. So you need to indicate the name of the electrolyte. You need to indicate the anode, the cathode in terms of the spoon and the silver electrode, as well as indicating the what? As well as indicating the battery there. Okay. So this will then represent your cell. So what are you going to have then when it comes to your cell? Remember we said that what are you going to connect to your cathode? Whatever that you want to be plating will be connected where? Will be connected to the cathode. And then what did we say? So this one here, what is it going to represent? It's going to represent your anode. Remember the anode is positive. and the cathode is what? Is negative. So we said that if you want to be plating with what? If you want to be plating with silver, then you are going to connect silver where? You are going to connect silver at the anode. And again, if you are plating with silver, the electrolyte needs to have what? Needs to have whatever that you have there as your metal for the silver. So again, when it comes to the marking criteria here, it says that you need to have the correct electrolyte, or use the correct electrolyte. So it will be your silver nitrate or silver acetate. Okay, so silver nitrate in this case, because they said what? On the question, they said that you must write the name of the electrolyte. So if they said that you must write the formula, then you would have what? Your AgNO3. But because they said you must write the name, that is why then we are going to write it out in words and say what? And say silver nitrate. So you will get a mark for using the correct what? For using the correct name there. And then it says silver electrode connected to the anode. So because remember we said that if we want to plate with what? If we want to plate with silver, then the silver needs to be connected to the anode. And it says a spoon to be electroplated. So whatever that we are going to electroplate will be connected where? Will be connected to the cathode. And then it says here, we need to have what? We need to have a battery, and then accept a cell if drawn or correctly drawn. So remember, a cell then will be represented in this way. So if we have more than one cell, that is when we have what? That is when we have a battery there. So that will therefore be how many marks? That will therefore be 3 marks there. Okay, so again, learners, if you have any questions, you can send your questions to the following WhatsApp number, 079-578-2908. You can send your questions to the following WhatsApp number, 079-578-2908. Then it says here, study the representation of an electrolysis reaction below and answer the questions that follow. Okay, so 6.1 says you need to give the name of the process which is represented above. Okay, so remember we had the electrolysis of copper 2 chloride. So immediately when we see that we have a key here, therefore the process will be called what? It will be called electroplating, and that is for how many marks? That is for 1 mark there. Then 6.2 says we need to identify the anode. Will the anode be the rod, or it's going to be what? Or it's going to be the key. So in this case, this one is the rod, and this one here is the what? Is the key. So remember we said we are going to use APE, whereby the anode is positive where? In the electrolytic cell. So if the anode is what? If the anode is positive, it therefore means that this is the anode and this is the cathode. And again, we said that we are going to use if we want to cover with what? If we want to cover with silver, then therefore we are going to use what? We are going to use the silver electrode there. Okay, so 6.2 says identify the anode. So if the anode is positive in the electrolytic cell, it therefore means that the anode will be represented by what? By the rod there, and not by the cathode. And then how did we then identify it? We used what? We used the battery, the positive terminal and the negative terminal there. Then 6.3 says define the term what? Define the term oxidation. So we said oxidation will be the loss of electrons, because we said we are going to use what? Oil, which is oxidation is what? Oxidation is loss. 6.4 says we need to write the reduction what? The reduction half reaction. Okay, so remember then the first step that you would have done was to do what? Was for you to break down the electrolyte. Number 2, it was then for you to then do what? For you to do migration of the ions. And then from there, after migration, that is when you are able to write the oxidation and the reduction half reaction. So remember we said that what are we going to have when it comes to the reduction half reaction? You are then going to look at your table 4b and look at silver, and you are going to write silver, that is in terms of what? In terms of a reduction, as the question is asking here. So when you do that, what is it that you are going to have? It therefore means that your silver, you are going to have Ag plus by 1 electron, and that is to give you what? Ag. It can also be Ag plus aqueous to give us what? Ag solid. So that is what will then represent the half reaction in terms of reduction. And then 6.5, it says give the name of the electrolyte in this reaction here. So the name of the electrolyte, we had what? We had Ag what? We had AgNO3. So with that AgNO3, we are therefore saying that it is going to be what? So the first part is representing the silver, and therefore the second part, which is the NO3, is representing what? Is representing the nitrate there. Okay? Then it says here, which energy conversion takes place during electrolysis? So if we are now dealing with the electrolytic cell, so we are therefore going to say that electrolytic cell is going to be what? Electrical energy to what? To chemical energy there. Okay. Then next, we have activity 3 there. It says the diagram below represents what? The electrolysis of what? Of copper to chloride there. Okay, so now on this one, we are saying that we already know that if we use APE, the anode is what? The anode is positive and the cathode is what? Is negative. So if we are then to break down this electrolyte there, what is it that we have? So if we are to break it down, copper to chloride, it will then be Cu2 plus, it's a transition metal, and what? And Cl minus. So we break down the electrolyte Cu2 plus and Cl minus. Cu2 plus in solution and Cl minus. So after breaking down the electrolyte, we are then talking about what? The migration of the ions. So if we are then to do migration, we said that the N ions are going to migrate where? To the anode, and the cations are going to migrate to the cathode. So it's going to be N ions migrate where? To the anode, and then the cations, they migrate where? To the cathode. Then from there, number 3, that is when we will be able to do what? Our redox then. So when we do our redox, we are therefore saying that because the chlorine has migrated to the anode, you are going to look at your table 4b and look at chlorine and write the oxidation half reaction in terms of what? In terms of chlorine there. And then you are going to look at your table 4b and look at what? And look at a Cu2 plus there. So the Cu2 plus that you will look at will be the Cu2 plus, the one that has Cu2 plus or Cu2 plus by 2 electrons, and that is to give us what? Cu there. So Cu2 plus and the one that has what? That has the Cu there. So then from this reaction, you are going to write your what? You are going to write your reduction half reaction. Okay. So now let us look at the questions. 5.1 says define the term what? Define the term electrolysis. So we are saying that it is a process in which what? In which electrical energy is converted into what? Into chemical energy. So remember, with your definitions, we are going to define according to the what? According to the examination guideline. Then 5.2, it says, is the electrolysis of copper to chloride a spontaneous or a non-spontaneous reaction? So remember we said that when it comes to a galvanic cell, it's a spontaneous reaction. So therefore, when it comes to an electrolytic cell, it will therefore be what? A non-spontaneous reaction. So what will then therefore be our reason then? Explain the answer to question 5.2. It is non-spontaneous because it requires what? It requires electrical what? Electrical energy. Because we said that it will convert what? Electrical energy is converted to chemical energy then. Okay, then it says write down the formula of an electrolyte that is used in the what? That is used in the cell above. Okay, so remember we had what? We had copper what? Copper 2 chloride. So with the copper 2 chloride, we are therefore saying that this will represent the copper. So, and the chloride will be represented by what? The chloride will be represented by the Cl there, or by the Cl2. Okay, so the formula, how did we then combine it? We are saying that if it is Cu2 plus, Cu2 plus is a what? Is a transition metal, and Cl minus, we find it on the periodic table where? On group number 7. So when you now combine the two, we are saying that we are going to cross multiply. The chlorine has a charge of -1, so the 1 will then go there to the copper. But remember, in chemistry then, if we have a 1, we are not going to write it as a 1. We are just going to leave it out. And the 2 there will then come from the what? Will then come from the copper. So hence then the correct formula will therefore be what? CuCl2. Then it says, at which electrode will the following observation be made? Write down only the anode or the cathode then. So 5.5.1, it says, where are the gas bubbles going to be formed? So remember, we said that if we have Cu2 plus and Cl, the chlorine, where has it migrated? The chlorine has migrated to the anode. And the Cu, where has it migrated? It has migrated to the cathode. So where are we going to have a formation of what? Of bubbles? You will then have to use what? Your table 4b, so that you are able to write what? Your half reaction in terms of what? In terms of the chlorine there. So if you look at your table 4b, you will see that you have what? You will see that you have Cl2 gas plus by 2 electrons, and that is to give us what? Cl minus aqueous on the right here. So if you are to write this reaction, and that is in terms of what? That is in terms of oxidation. Remember, you are going to write it from the right to the what? From the right to the left. So when you do that, it means that you are going to start with 2Cl minus aqueous to give us what? Cl2 gas plus by what? Plus by 2 electrons. So looking at the question here, it says gas bubbles. Where are the gas bubbles formed? Okay, are the gas bubbles formed by the anode, or are the gas bubbles formed by the cathode? So remember, when it comes to the anode, then we are going to associate the anode with what? With oxidation. So we can see that where do we have those gas bubbles? We have those bubbles by the chlorine gas then. So remember we said that the chlorine gas is what? It's green in color, and therefore it is going to be forming what? It is going to be forming bubbles then. So it therefore means that our correct answer then will therefore be the what? Will therefore be the reaction when it comes to what? When it comes to the anode. And then if we are then saying that we are going to have a formation of bubbles there, we then also need what? We then also need the half reaction when it comes to what? The half reaction when it comes to the copper there. So then for this one, it says a brownish deposit is what? A brownish deposit is formed. So already know that by the anode, we have what? We have a formation of gas bubbles. So we are therefore saying that a brownish deposit will therefore be formed where? It will therefore be formed by the cathode there. Okay. Then the next one says, define the term what? Define the term reducing agent. Okay, so we had already defined the reducing agent. It says it is A, so the key word here will be what? Will be the word substance. That is what? That is oxidized or that loses electrons, or it will be a substance that will do what? A substance that will undergo what? Oxidation. Then it says for the cell above, we need to write down the what? We need to write down the oxidation half reaction. So again, you are then going to look at your what? You are then going to look at your table 4b. If you look at table 4b, remember we said that the Cl minus, where is it migrating to? The Cl minus is migrating to the anode. Because the Cl minus is migrating to the anode, we are therefore saying that we are going to write this chlorine ion, or we are going to write the chlorine that is in terms of what? Oxidation. Why? Because that is where we have the migration of what? The migration of the chloride ions. So if we write the chlorine in terms of oxidation, we are saying that we are going to write it from the right to the left. And when we do that, it will be 2Cl minus right to the left. So remember, we are going to use a single arrow or 2Cl minus aqueous, and that is to give us what? Cl2 gas plus by what? Plus by 2 electrons there. So this will then represent our what? Our oxidation half reaction. And then we need what? We need to write the reduction half reaction. So remember, if we said that the Cl minus has migrated where? Has migrated to the anode, that is from the electrolyte, then the Cu2 plus, where has it then migrated to? The Cu2 plus has then migrated to the cathode. So if the Cu2 plus has migrated to the cathode, we are then going to look at what? We are then going to look at the table, and then we need to write there. We are then going to look at the table, look at copper, and then you need to write the reduction half reaction in terms of copper. So when you write the reduction half reaction in terms of copper, what is it that you are going to do? You are going to copy and paste. So when you copy and paste, you will see that you have Cu2 plus aqueous plus by what? Plus by 2 electrons. Because you have now decided that this is your reduction half reaction, remember, you are going to use a single arrow, and that is to give us what? That is to give us Cu what? Cu solid. Okay, so that will be our reduction half reaction. Then the next question says you must write the what? The net reaction. So how are you going to write the net reaction? It therefore means that you are going to need a combination of the oxidation half reaction as well as the reduction half reaction. So what is it that we had for the oxidation half reaction? We had 2Cl minus aqueous. So for the oxidation half reaction, remember we said we wrote it right to left, and then for the reduction, left to right. So we had 2Cl minus aqueous plus by what? Or to give us Cl2 gas plus by what? Plus by 2 electrons. So for us to write the net reaction, then what are we going to do? We are then going to check the number of electrons. So if the number of electrons are balanced, we can therefore write whatever that we have on the left and whatever that we have on the right. Okay. So now we see that for chlorine we have 2 electrons, and then for copper we also have 2 electrons. So from there, what are we going to do? We are therefore going to write whatever that we have on the left. And what do we have on the left? We see that we have 2Cl minus aqueous plus by, what else do we have? Cu2 plus aqueous. And what is it that we have on the right? On the right, we have Cl2 what? Gas plus by what? Plus by Cu what? Cu solid. So it's this as Cl2 gas and the Cu solid. So for you to be able to write down the correct net reaction, you need to make sure that you write your correct oxidation half reaction and that you are also able to write the correct what? Reduction half reaction. From there, what are you going to do? You are going to check the number of electrons. If the number of electrons are not balanced, then you start by balancing. But if the number of electrons are balanced, then you can write whatever that you have on the left. So in this case, we had 2Cl minus aqueous and what? And Cu2 plus aqueous. And we can therefore write whatever that we have on the right. We had what? Cl2 gas and what? And Cu solid there. Okay. Then the next one says the diagram below represents an electrochemical cell used to decompose what? A concentrated copper 2 chloride solution, and that is using what? That is using inactive what? That is using inactive electrodes. So therefore it means that if we are going to use inactive electrodes, they are not going to participate when it comes to what? When it comes to the half reactions. Okay, so what is it that we have as the electrolyte? It says we have concentrated copper 2 chloride. So if we are able to break it down, then copper 2 chloride, we said it's Cu2 plus and what? And Cl minus. So from there, we can then also identify the anode and the cathode. The anode will be the longer line and the cathode will be the shorter line. So electrode B, we can already see that is the anode, electrode A, that is the cathode. From there, we can talk about what? Migration. The chloride ions, where is it going to migrate to? It's going to migrate to the anode, and the Cu2 plus, where is it going to migrate to? It's going to migrate to the cathode. Okay, then it says when the cell is functioning, a gas is released at electrode what? At electrode A, whilst the electrode B is what? Is coated with a reddish brown layer. So if a gas is released, then we know that that is actually going to be representing the anode. And then it says here with a reddish brown, we are going to associate it with the cathode there. Okay. Then 7.1 says we need to define the term what? Electrolyte. So definition, we are going to define it according to the what? According to the examination guideline. So it says an electrolyte is a substance of which the aqueous solution contains ions, or a substance that dissolves in water to give a solution that does what? That conducts what? Electricity. Then 7.2 says what type of an electrochemical cell is this one? So we can see that the two electrodes are represented in one beaker. So therefore, that is going to represent what? That is going to represent the electrolytic cell there. Okay. So learners, we have run out of time. So I will suggest that you can then continue and do the rest. And with that said, I would like to say thank you very much, learners, and I would like to leave you with the words of Nelson Mandela, which says, "It is in your hands to create a better world for all who live in it." With that, thank you very much, learners, and I'll see you next time.